All right, it's time for the melting point test. As you can see, we have all six compounds on a small piece of metal mounted on a ring stand with a candle underneath. Each of the six compounds is white, and with the exception of the calcium chloride, they're all crystalline. One thing to note with calcium chloride, probably doesn't show up on the video, but it looks almost as if it's wet, and that's because it is. Calcium chloride is deliquescent, which means it absorbs moisture from the atmosphere, and so the calcium chloride clumps look just a little bit shiny. That's these guys right here. This is sucrose, this is sodium chloride, this is potassium iodide, here's the phenyl salicylate, and this is the citric acid. You can see them displayed here on this page as well. So one of the distinguishing characteristics of ionic compounds is that they have relatively high melting points, and covalent compounds have relatively low melting points. So what we will do is we'll light our candle and stick it back underneath the metal plate, which will then heat up, and we're going to just record the order in which our compounds melt. And if they, well, first of all, if they do or do not, and then the order in which they melt to establish their relative melting points. So I'm going to take the candle out, light it up, and then we'll be ready to begin. Back underneath in the middle of our plate here. You can see our first compound to melt rather quickly is the phenyl salicylate. That must mean it has a very low melting point. The second compound to begin melting, you can see right here, is the citric acid. It's beginning to melt. And then you can see also the sucrose at the back has started to melt as well. And so again, just to review, phenyl salicylate was the first compound to melt, then the citric acid, and third, the sucrose. And we haven't seen anything out of the calcium chloride or the potassium iodide or the sodium chloride yet. We'll give it another little bit here before we shut everything down, just to see if something happens. It's kind of nice. It smells like toasted marshmallows or roasted marshmallows right now from the sucrose. All right, we're going to take our candle out now. So we're not going to see any other significant changes. So one last observation to note here. Again, our phenyl salicylate melted first, then the citric acid, then the sucrose. But our calcium chloride, our potassium iodide, and our sodium chloride did not melt. All right, guys, this is the solubility and conductivity portion of our experiment. Let's run through our setup. So this portion of the experiment, we're going to be using a well plate. That's this device right here. The well plates have individual containers, and in each of these containers, I've placed a small amount of our 6 compounds: sucrose, sodium chloride, potassium iodide, phenyl salicylate, citric acid, and calcium chloride. In this column, I'm going to add 10 drops of water to each of the well plates, or each of the wells, and we'll observe what happens to our compound in that well, if it dissolves or does not dissolve. And in this column, I'm going to add 10 drops of ethanol. As you may have noticed, when I went to add some deionized water, my bottle just simply started squirting. So I'm going to go run and grab another bottle real quickly, and then we'll begin. To save us a little time in counting, rather than add 10 drops, I'm going to fill the well plate just cover the bottom of the well plate so we can get an idea if we're going to see these guys dissolve in water or ethanol. All right, then we're going to come back. We're going to do the same thing here with the ethanol. All right, so we will let those ones sit, and then you will get to make the distinction. Did the compound dissolve or did it not dissolve? Go ahead and check your data. All right, in the next portion of the experiment, we're going to be using a conductivity meter to test the solution in each well to see whether or not it conducts electricity. When the conductivity meter is turned on and it comes in contact with a metal object or something that can conduct electricity, we'll see the lights turn on. So let's go ahead and begin testing here. I'm going to place it in the solution. And in this first solution, test is complete. Between tests, I'm going to make sure that I rinse the leads off thoroughly with deionized water to make sure that there's no contamination. Here's solution number 2. This is the sodium chloride solution. Let's see, we get light turn on there, indicating that it's conducting electricity. Okay, let's try the potassium iodide solution. Again, we see the light turn on. Great. We're now going to test the phenyl salicylate. One more time. Now the citric acid. And we can see the light comes on there. And our last solution, the calcium chloride. All right. So in your data table, you should be marking down whether or not the solution conducted electricity. So this is a conducts or does not conduct electricity. And again, when we're looking at solubility, it dissolves or it does not dissolve. You need to make that distinction for these 6 compounds in water, and then again, these 6 compounds in ethanol. All right, so that's the end of the solubility and conductivity portion of the lab. At this point, you should have all the data that you need to be able to complete your CER statement and answer our 2 analysis questions.